Let us perform the titration of potassium permanganate solution with the help of standard solution of oxalic acid. Now first of all, you have to rinse the burette with the help of potassium permanganate solution. Add small amount of potassium permanganate solution into the burette, and then you have to remove the burette and rinse it properly. Now this rinsing is done in order to remove the water present inside the inner wall of the burette. You have to remove the burette from the burette stand, place it on the horizontal position and rotate it in such a way that the inner surface of the burette will be coated with potassium permanganate solution. This process is done to assure that the strength of potassium permanganate solution may not be altered. Now, after rinsing, you have to throw the content or the potassium permanganate solution into the sink, and then you have to clamp the burette on the burette stand and then fill the burette with the help of potassium permanganate solution. Now I have thrown the potassium permanganate solution after rinsing into the sink, and now I have clamped the burette with the burette stand, and then now I am adding potassium permanganate solution into it. Now please assure that the knob of the stopper of the burette will be closed at this point. Now I am adding potassium permanganate solution with the help of a funnel, and after filling the potassium permanganate solution, you have to remove the air gap present inside the burette with the help of a stopper. You have to open the stopper to remove the air gap present inside the burette. And then you have to adjust the upper meniscus of the solution up to the 0 mark as indicated on the burette. You have to remove the air gap and then adjust the initial reading, that is the upper meniscus of the potassium permanganate solution must coincide with the initial reading, that is nothing but 0 ml. Now then you have to rinse the pipette with the oxalic acid solution. Here is the pipette filler. I am inserting the pipette inside the pipette filler, and then you have to rinse the pipette with the help of standard oxalic acid solution taken in the reagent bottle. Here I am rinsing the pipette with the oxalic acid solution. Now suck small amount of oxalic acid into the pipette and place it in horizontal position and rotate it such that the inner surface of the pipette will be coated with the standard oxalic acid solution. And throw the content into the sink after rinsing. Now fill the pipette with oxalic acid solution with the help of filler and adjust the lower meniscus of the liquid up to the scratch mark as indicated on the pipette. I have taken here 10 ml pipette. I have filled the pipette with the help of oxalic acid, and then I am adjusting the lower meniscus of the liquid up to the scratch mark as indicated on the pipette. Now for colorless solution or transparent solution, you have to observe the reading at the lower meniscus of the liquid. The scratch marks should coincide with the lower meniscus of the liquid, and then you have to transfer this 10 ml of solution into the conical flask. Now I am transferring the oxalic acid into the conical flask. Now for transferring the last drop of the liquid, you have to tilt the conical flask and touch the lower tip of the pipette with the base of the conical flask, and the last drop of the liquid will be transferred into it. And here you can see the extra amount of oxalic acid left in the lower tip of the pipette, and this is extra liquid, so it must not be transferred into the conical flask. Now then you have to add 1 test tube full dilute sulfuric acid into it. Now then heat the mixture over the burner up to 60 to 70 degrees centigrade. Now this redox reaction is a slow reaction. The rate of this redox reaction is slow, and that is why in order to increase the rate of the reaction, you have to heat the content or the mixture up to 60 to 70 degrees centigrade. Now here you can see the water vapor is condensing at the neck of the conical flask. And when it starts condensing at the neck of the conical flask, it indicates that it has been heated up to 60 to 70 degrees centigrade. You don't have to heat the mixture or boil the mixture. Always remember, don't boil the mixture. Now start titrating the mixture in hot condition till the permanent pink color is obtained with constant stirring, and record the reading. Here the reading comes out to be 11.3 ml. Now this one is the initial reading. Now the first reading, it means this is the final reading of the burette, but this is the first experiment and we have recorded the first final reading, and it comes out to be 11.3 ml, and record this reading. And this will give you the information that our endpoint lies between 10 to 11.3 ml. Now next you have to repeat the same experiment number of times till the two concordant reading will be obtained. Here you can see the initial reading, that is the final reading of the burette in the first experiment, comes out to 11.3 ml. Now then you have to repeat the experiment. Now again I am transferring the 10 ml of oxalic acid solution into the conical flask. Always remember, you don't have to rinse the conical flask. Never rinse the conical flask. It should only be washed with water. Now after throwing the content, I have washed the conical flask with water, and now again I am transferring the 10 ml of oxalic acid solution in order to repeat the titration again. For recording the second reading. Now transfer 10 ml of the solution into the conical flask. Now then you have to add 1 test tube full dilute sulfuric acid into it. Now transfer the last drop of the liquid accurately, and then add 1 test tube dilute sulfuric acid into it. I am adding 1 test tube dilute sulfuric acid into it, and then you have to heat the content over the burner up to 60 to 70 degrees centigrade. Always remember, never boil the mixture. And you can see that the water vapor is condensing at the neck of the conical flask, and it will indicate that the mixture is heated up to 60 to 70 degrees centigrade. Never boil the mixture. Now next, titrate it against potassium permanganate solution. Fill the burette first up to the initial 0 reading. Here you can see that the initial reading of the burette is again 0.0 ml, and then titrate the mixture under hot condition by adding slowly potassium permanganate solution with continuous stirring. Now you can see that first of all the pink color appears, and on continuous stirring it disappears. You have to continue the titration till the permanent pink color obtained. And since you have seen that during recording the first reading, our reading comes out to be 11.3. So after 10 ml onwards, you have to add drop by drop. Now here I am adding drop by drop in order to get, so that we can get the exact end point of the reaction or titration. Add drop by drop with continuous stirring till the permanent pink color appear. Now this is the end point of the reaction, exact end point of the reaction, and now you note down the final burette reading, and here it comes out to be 11 ml, 11.0 ml. Now you can see that the final burette reading is nothing but 11.0 ml. Now in this way you have to prepare the observation table in which you have to report the first reading, that is the first experiment, and the two consecutive reading, that is concordant reading. Now here the aim of the experiment was to prepare 100 ml of M by 20 oxalic acid solution, and using this solution you have to determine the molarity and strength of given potassium permanganate solution. This is the complete aim of the second experiment of class 12th. Now next, let us draw the observation table for titration. Now the first observation, you have to write the molarity of the standard solution, that is prepared oxalic acid solution. As you have seen in the previous video, it comes out to be 0.0571 molar. It means the standard solution of oxalic acid has the molarity of 0.0571 molar. Now next observation is that you will pipette out 10 ml of oxalic acid solution during each titration. It means the volume of oxalic acid solution taken during each titration will be equal to 10 ml. Now this value you can report it in the form of table also. Now next you draw the table. This table contains 3 columns. This one is the common column, and the heading is burette reading. You have to write down the initial burette reading and final burette reading in these 2 columns, and here you will get the volume of potassium permanganate solution, that is KMnO4 solution used, by subtracting the value of final reading from the initial reading. Now this table contains 3 observations. The first one is the initial one. The first experiment or the first titration, you will get the value in the video. As you have seen, it comes out to be 11.3. Initial reading was 0.0 ml and the final burette reading was 11.3 ml. On subtracting these two, we get the volume of the KMnO4 solution used is equal to 11.3 ml. Now here are the 2 consecutive readings which we get the same value. It means if you get the 2 consecutive reading, final reading of the burette as the same, then these 2 readings are known as concordant reading, and here the concordant reading is equal to 11.0 ml. Now let us calculate the molarity and the strength of given potassium permanganate solution. In calculation parts, first of all, you have to write down the balance redox reaction on which this titration is based. Now here as you can see that 5 moles of C2O42 minus N reacts with 2 moles of MnO4 minus N in presence of 16 moles of H plus N to give rise to the formation of 10 moles of carbon dioxide, 2 moles of Mn2 plus N and 8 moles of H2O. And this is the balance redox reaction. Now for calculation, we apply the formula M1V1 upon N1 is equal to M2V2 upon N2. Here N1, M1 is the molarity of oxalic acid solution, that is the standard solution, and it was nothing but 0.0571 molar solution. Now next, the volume of oxalic acid taken during each titration was nothing but equal to 10 ml. Now this N1 is the balanced coefficient of oxalate and in the balanced redox reaction, and here the value of N1 is nothing but 5. Now second, the molar M2 is the molarity of potassium permanganate solution, and that you have to calculate, and this V2 is the volume of potassium permanganate solution used during the titration, that is 11.0 ml. It is nothing but the concordant reading. Here you have to mention the concordant reading. Now next, N2 is the coefficient of KMnO4 minus and in balanced redox reaction, and here the value of N2 is nothing but 2. Now you have to mention these variables. First of all, you have to define what is M1, V1, N1, M2, V2, N2, and write down the respective values of these variables. Now next, you have to substitute the values of variables in the above equation mentioned formula. Now here the molarity of oxalic acid is 0.0571 multiplied by the volume of oxalic acid, that is 10 ml, divided by the coefficient of oxalate, and that is nothing but 5, will be equal to M2 multiplied by 11.0, that is the volume of KMnO4 solution used, divided by the coefficient of MnO4 minus ion, that is nothing but 2. On solving this, we get the molarity of KMnO4 solution is equal to 0.020 molar. Now here the molarity of given potassium permanganate solution will be equal to 0.020 moles per liter. Now for calculating the strength of the solution, you have to multiply the molarity of KMnO4 multiplied by its molar mass. Here the molar mass of KMnO4 is nothing but 158 grams per mole. Now multiply the molarity with 158 grams per mole. We get the weight strength of the solution equal to 3.16 gram per liter. In this way, we can calculate the strength of the solution, and it comes out to be 3.16 grams per liter. So you have to report the result, that is nothing, the molarity and strength of given potassium permanganate solution is 0.20 moles per liter and 3.16 grams per liter respectively. And this is the answer of the aim of the experiment. It means where you have to determine the molarity and strength of given potassium permanganate solution. Thank you.